So that's what I kind of do at the beginning of class. There's probably a more streamlined way to do that, but that's what works for now. Okay, so I think we're all set. Okay, so number 18, and this is in 7.1. Okay, so this is 0.5x. So the biggest thing with this is we're kind of back to our system of equations, right? Solving our system of equations before we got into matrices. And I'm going to make sure that I write my problems correctly. Okay, so I have one equation and I have another equation. Sorry, I'm just really being careful that I write it correctly. Nothing worse than writing the problem wrong to start, right? Well, maybe forgetting a negative sign for these problems. Okay, so we're back in 7.1. It's a system of equations. This one happens to be a system of linear equations. And what they want us to do is solve the system by the method of substitution. Use a graphing utility to verify your results. So what we did and what we were thinking about, Jennifer, right, is we thought about, let's take the second equation and solve for x because it looks like everything divides by 0.2. Okay, so we had 0.2x equals positive 1.6y. So I just added 1.6y to both sides of the equations, minus 3.6, right? And then if I want to solve for x, I'm going to divide everything by 2/10. Okay, so I end up with x equals 8y, right? And minus 18. Okay. Did anybody solve it a similar way or pick a different number? Crickets on the chat. Okay. Then I'll keep, no, you did it differently or the same? Oh, you didn't do it yet. Okay. I appreciate your honesty. All right. So now we've solved one equation for one variable, right? Then we're going to substitute that equation into our other equation. Okay. So let's plug it in and let's color code it. So this is our first equation, right? So we have 0.5 times x, right? We have times x right here. But instead of x, we're going to insert in this value of x. Oh, slightly different color blue. So 0.5 times 8y minus 18. Okay. And then we're going to keep going with our original equation. Plus 3.2y equals 9. 9.0, not 90. All right, so now I need to just distribute my 5/10, right? So I end up with 4y minus 18 plus 3.2y equals, and I'm just going to leave it at 9, okay? 3.2. Sorry for my crazy writing. So if I add these together, I get 4y plus 3.2y is 7.2y. And I'm also at the same time going to add 18 to both sides, and I end up, should the 8, oh yes, thank you. Is that what we did last time, Jennifer? That would be helpful. Thank goodness for erasers, right? Yes, this should be a 9. So then we have to add 9 to both sides. Oh, we did all kinds of things, huh? All right, so then we add, and it should be addition, right? The original problem is addition. Ended up with 18. So are we on the right track now, Jennifer? I think so too. All right, so if I divide both sides by 7.2, I get y equals 2.5, right? And then if I want to figure out what x is, then I need to plug that back in up here. And this is a mess. I apologize. Always a mess on the computer screen, right? So I need to plug that back in up here to my x. And I'm going to kind of pull that off to the side. So x equals 8 times 2.5 minus 18. So that's 16. 20 minus 18. So x equals 2. Okay, so now our solution is 2.5. But as we know that our, as we know from doing these problems, sometimes you get on the wrong track. So the easiest way to check them is to put them in a graphing tool, right? So you could put these two equations in your TI calculator, or we can put it in Desmos and see where they intersect. So let's pull up Desmos and type in our equations if it wants to pull up for us. Okay, so very quickly we'll type it in 0.5x, but not too quick because we don't want to get it wrong. Okay, so you can see our two linear equations, right? It's what we would expect since these are linear equations. And then we can see that our point of intersection is at 2.5. So there we go, Jennifer. With a whole lot of work, we got there, right? Okay. Any other questions that we can work our way through? Nope. All right. Well, if there is, let me know. We are going to dive into matrices. Okay. So the next section is 7.5. Let me pull up the notes here. Scroll a little bit. Okay. So if you remember on actually last Thursday and on Monday, we talked about converting systems of equations to a matrix and then using getting those into row echelon form or reduced row echelon form in order to solve those equations. Okay, so we kind of step through these processes of how to do that. And today I think we're kind of going to take a step back and we're going to talk about what, using a matrix, what kind of operations can I do to a matrix? So the book is a little weird in the way that we do it. I understand why they put this section that we just did first, because the section that we just did, 7.4, really relates to solving systems of equations, systems of linear equations. So they put it right after we were solving systems of linear equations. And now we're going to shift a little bit and we're going to talk about matrices in general and what operations we're allowed to do on matrices. And then that's going to lead us to another technique that we can use with matrices down the line. So that's kind of what 7.5 is. There is not a lot of notes at the top, but there is a lot in your book. So I'm going to basically be teaching the concepts through the problems on here, if that makes sense. So the first thing is just a review of when we talk about the order of a matrix, that actually becomes really important. The order of a matrix becomes really important when you're talking about operations with matrices. So when I mean operations with matrices, I mean, can we add two matrices together? Can we subtract them? Can we multiply them by a scalar? Can we multiply two matrices together? And the answer to all that is yes, you can do all that. But when you do that, you have to be really careful about the order of the matrix. So if I scroll up a little bit, sorry for all the scrolling on there. If you recall, when we talk about a matrix, we talk about the number of rows by the number of columns. Okay, so and that's how we actually define the matrix. So if we have m rows and n columns, this would be an m by n matrix. It's hard to say over a call, right? So for example, this number 2 down here, if we wanted to determine the order of this matrix has 1 row and 4 columns. So this would be a 1 by 4 matrix. Okay. The second matrix has 3 rows and 4 columns. So this would be a 3 by 4 matrix. And it's going to be really important that you're able to order your matrix or your matrices, because that there's some rules about columns and rows matching up that we're going to get to. So I just wanted to review that with you guys. Okay. So the first thing that we're going to talk about, I think, is pretty, like, it makes sense when you see it. Let's make this a little bigger here. There we go. And so I'll just pull this over. Oh, did it open in Paint for me? It didn't. Okay, so these first two problems, I think they make sense. So it's basically the definition of if two matrices are equal to each other. Okay, so in order for two matrices to be equal to each other, they have to have the same order. Okay, they have to have the same m by n. So you can see here that number 2 and number 4 are two matrices. This one is a 2 by 2 matrix equals a 2 by 2 matrix. This is a 3 by 3 equals a 3 by 3, but they don't have to be square matrices. They could also be, you could have a, oh, that's not what I wanted to do. Undo. There we go. You could have a 2 by 1 is equal to another 2 by 1. Okay. And the definition, if two matrices are equal to each other, one, they both have to have the same order, right? The other element that's important is that each corresponding entry is also equal to each other. So in this very simple 2 by 1 matrix equals 2 by 1 matrix, we have that our first row, first column, our x here, equals our first row, first column here. So x would equal 1, right? And y would equal 2. Y would equal 2. So that's kind of our basic. You can have two matrices equal to each other. You have to have them have the same order. And then every entry in the matrix has to be equal to each other. So it's pretty, I think from there, the actual doing of the math is actually pretty easy, right? So in example number 2, we can see this 2 by 2 matrix. We have our first row, first column, -5 equals -5, right? Our second row, first column, we have a y. And then in that same position, the same entry, second row, first column, we have 12. So we know that y equals 12, right? And then up here in our first row, second column, we have an x. and first row, second column, we have a 13. So x equals 13. Pretty easy peasy, right? It's a little more complicated in 4, but not much more complicated than that. So in our first row, first column, we have x plus 4, and that equals 2x plus 9. So in order to solve for x, we would just set those two equal to each other and solve. So I'm not even going to do that. I think you guys can handle that. All right, so that's kind of the baseline, the entry in. Then we're going to talk about adding matrices, subtracting matrices, and multiplying by a scalar and what that means. Okay, so that's kind of the next jump is we're going to talk about adding, subtracting, and multiplying by a scalar. So just a kind of reminder / teaching, we can call our matrices by these capital letters here. So you'll see that, let's just look at example number 6. We'll just start with 6 right here. Okay, so we're given two matrices. We have matrix A, which is a 2 by 2 matrix, right? And we have matrix B, which is also another 2 by 2 matrix. And we can call those capital A and capital B. That's our nomenclature for matrices. In your TI calculator, right, you'll also see, or some books, some math books, you also see matrices referenced like this. So the capital letter with the matrix brackets around it. So both of those are ways to write, to represent a large matrix. So this matrix A is a 2 by 2, but it could be a 200 by 200. And if we want to do operations on it, we can just reference as matrix A. We don't have to write the huge matrix out every single time. Making sense so far? I know some of you have seen matrices before and some haven't, so I'm kind of stepping through each one. Everybody with me still? All right. Sarah's with me. Yay. Cool. Aiden's there. Awesome. Okay. Cool. Just to make sure everybody's still there. All right. So we're going to start off with adding and subtracting matrices. Okay. So you are allowed to add and subtract matrices together. So we can do A plus B or A minus B. But there is one condition. So you are allowed to add and subtract matrices together if they have the same order. Same order. So as long as my two matrices that I'm adding and subtracting together have the same order, they're the same number of rows and columns, then I can perform that operation. So if I look down my examples here, number 6, I have a 2 by 2 and a 2 by 2 that I'm adding together or subtracting. I can do that, right? 8, I have a 2 by 3 and a 2 by 3. So I can add and subtract these together. 10, I have a, let me make sure, 5 by 3 and a 5 by 3. So I can add those together. Once I get to 12 right here, 12, matrix A is a 3 by 1 matrix. Okay. And matrix B is a 1 by 3 matrix. So this one, I already know that I cannot actually add A plus B or subtract A plus B in the form that they're in right now because they're not the same order. All right, so that's pretty much it. Then the adding and subtracting is actually super easy. So let's go back up to example number 6, right? If I want to add A plus B together, what I'm doing is I have matrix A, which is 1, 2, 2, 1, okay, and -3, -2, 4, 2. So I'm just writing out what matrix A and matrix B are. And then when I add them together, I am going to add each corresponding entry together to make a new matrix. So the first row, first column is going to be 1 plus negative 3. 1 plus negative 3. The second row first column, okay, second row first column is going to be 2 plus 4. The first row second column is going to be 2 plus negative 2. And the second row second column is going to be 1 plus 2. Now, obviously, once you get into this, I'm being very intentional about every detail, but you don't have to write out the, sub addition in there. So my first element would be 1 plus negative 3, which is negative 2. 2 plus negative 2 is 0. 2 plus 4 is 6. And 1 plus 2 is 3. And that's a 6, not a B. So you're really just going to add the 2 together. So then what do you think happens when you subtract them? You're going to do the same operation, right? You're going to subtract each element. So instead of 1 plus a negative 3, you're going to have 1 minus a negative 3, 2 minus a negative 2, and so on. So I think matrix addition and subtraction is pretty straightforward, right? Pretty easy. Just add those elements together. Okay. Now, so that's addition and subtraction. So now let's talk about multiplying by a scalar. So if you're adding and subtracting, remember they have to be in the same order. Oops. There we go. Okay. So, and then you'll see in this, the homework, they said, find, if possible, a plus b, a minus b, 3 times a. Okay. So this is multiplying by a scalar. Multiply by scalar. Let's see. Okay. So in this case, they want you to multiply matrix A by 3. Right? And so what that means is that every entry in matrix A is going to be multiplied by your scalar. So in this case, it's 3. So it's going to be 3 times my first row, my entry in my first row, first column, 3 times my entry in my second row, first column. So basically, a scalar multiplication doesn't have any rules in terms of order, right? Because you're just taking every element, every entry in your matrix, and you're multiplying it by a number, which is your scalar. So this doesn't have any rules about the order being a certain size. So for example, if I wanted to evaluate 3a for problem number 6, right? It's 3a would be equivalent to, and you can, sometimes you'll see it written like this, 3 times 1, 2, 2, 1. And basically, it's kind of like you're distributing that 3 to every element in your matrix, right? So you're going to have 3 times 1 equals 3. 3 times 2 equals 6. 3 times 2 equals 6. And 3 times 1 equals 3. So that would be multiplying by a scalar. So then the last kind of example is that we're going to put this all together. So you see that for each of these matrices, they're asking you to add them together, subtract them, multiply by a scalar, and then D kind of combines the two. So let's do example D for problem 6, 6D. So 6D is 3A minus 2b. So 3 times matrix A minus 2 times matrix B. So what we're going to do when we have, it's just like order of operations, right? We're going to do our multiplication first, and then we're going to do our subtraction. And we've actually already solved for 3a. So for 3a, we know that is a matrix that is 3, 6, 6, 3. Okay. We also have a choice with our minus 2b. So we could either just multiply by a scalar of positive 2 and then subtract the two matrices, or you could, oops, I'm going to scroll there, or you could apply the negative to 2 and you multiply by a scalar of negative 2 and then add the matrices together. So it doesn't actually matter either way what we want to do for that. Let's just go ahead and multiply by negative 2. Okay, so I'm going to kind of work this off to the side. Give myself a little room over here. The benefit of working online, right? You can just make your paper longer. All right, so what I mean by that is over here, I know that B is negative 3, negative 2, 4, and 2. Okay, I'm going to multiply by, I'm going to make this plus a negative 2. So I'm going to multiply by B by negative 2. So that means every element in here needs to be multiplied by negative 2. So it'll be negative 2 times negative 3, which is positive 6. Negative 2 times negative 2, which is positive 4. Negative 2 times 4, which is, and these negatives and dots are looking the same. This is negative 8. And negative 2 times positive 2, which is negative 4. So this is negative 2b that I just evaluated. So now I'm going to put it back into my original matrix equation that I'm solving and get 6, 4, negative 8, negative 4. So then when I go to add them together, it's just going to be every entry that corresponds, I'm going to add up. So I have 3 plus 6 is 9. 6 plus 4 is 10. 6 plus negative 8 is negative 2. And 3 plus negative 4 is negative 1. And that's my kind of sloppy solution, right? It's a sloppy matrix, but you guys get it. There we go. Okay, so with that, if you were looking at the problem, I'm just looking here to make sure that I did all my math right. Yep, okay, we should be good. All right. If you look at the original problem, okay, it says for each of these matrices, find if possible a plus b, a minus b, 3 times a, so a scalar times a, and 3a minus 2b. Use the matrix capabilities of a graphing utility to verify your results. Okay, so this is where your TI calculator comes in super handy, and I meant to pull up a screenshot. I might do that here in a second, because it actually has a really powerful matrix capability in there. Desmos, unfortunately, does not do matrices. So give me 1 second. I'm going to pause the screen for 1 second. I'm web searching for matrices on a TI calculator so that I can show you where it's at. Um, so I don't randomly web search out there. There are obviously lots of YouTube videos out there about how to solve for matrices, but you'll see that, and I think I showed you guys where that button is. I'm trying to find a picture. Oh, are these images? So your matrix button, I believe, is right here. It's right up here on your calculator. And you can go in there and there's 3 different choices in your matrix button on your TI calculator. One is just the name, which just means that you want to do some type of operation with your matrix. And then another is where you actually put the entry in. I think it's the 3rd choice over. So if you go in there, you can actually define what matrix A and matrix B are in your TI calculator. And I can show you this on Monday as well. And then you can actually perform operations in your calculator just like you would with addition and subtraction. So once you've said, well, matrix A is 1, 2, 2, 1, and matrix B is, I forget what it is, then I could type into my calculator A plus B, and the TI will calculate what the matrix is when I add it or subtract it. So the hard part, not really the hard part, but the hard part is actually setting up the matrix in your TI. But I guess the most work part, and then your calculator actually will perform these basic matrix operations for you. So I can, if you guys want to play with that and try that, I can also show you how to do that. And there's obviously a lot of YouTube videos about how to do basic matrix operations too. Okay, so that's for people that have the TI calculator. If you don't have a TI calculator, Desmos fails at matrices. They have not incorporated that yet. So the best thing that I found was this matrixcalc.org, and this is in English. So this is it's a more basic matrix tool because the TI calculator, you can put in, multiple matrices. You can have A through F. This one, you just have 2 matrices that you're able to work with, but it still works for the purposes of what we're trying to do. So, for example, if I was trying to do number 6 and use this matrix calculator to check my work, the way this calculator works is that they give you a set 3x3 matrix, and you can actually subtract the number of rows and columns by using this, or add on if you want a bigger matrix. They actually, if, for example, you had I'm trying to think, if you had number 8 that you were trying to do, then you would just leave your last row blank. So number 8, if you have your paper, is a 2x3 matrix. So we would just leave this last row blank, and that would still perform the operations. So I'm going to do number 6 since that's the one that we did. So if I'm doing number 6, conveniently, I have my matrices are named A and B, so I'm going to put those same matrix entries in here. So I have a matrix A that is 1, 2, 2, 1, and matrix B is -3, -2, 4, and 2. Okay. So then if I want to do some basic matrix operations, you can see here that this calculator has those available to you. So I could just do, what is A plus B? And so then it shows me, well, matrix A is 1, 2, 2, 1. This is a matrix B. When I add them together, I get -2, 0, 6, 3. You can obviously do A minus B, right? And that'll evaluate your matrix for you. We haven't talked about multiplying matrices yet, but you can also put in a formula here. So for example, we did 3 times A, right? 3 times A. And that's where we multiply a scalar by our matrix. And then our last problem was 3 times A minus 2 times B, capital B. So we get 9, 10, negative 2, 1, which is, I think, what we got when we solved. So that was good. Okay. Sometimes I think it's more work to use the matrix calculator than to actually just do the work, right? Sometimes to type everything in is more work. But obviously, if you're working with I mean, matrix can be huge, right? They could be data that you've collected over, a year, and every day has an entry in it, and you want to do some operation on that matrix. Then obviously, being able to use some matrix calculations is going to be really helpful to you. Okay. How do you guys feel about those? Feel ready to tackle matrix addition and subtraction? Okay. Okay, till you try it, right? It's not too bad, actually. I think you guys can do it. All right, so then there's a few more examples, and I want to just do one in each example to go through that. And then honestly, what we'll do is we'll probably just wrap up with matrix addition and subtraction today. And then starting in your homework in number 25, 25 through 41, is where we actually multiply two matrices together. And that I will save for Monday probably, because that's a whole different ballgame. Is multiplying matrices. That when you have matrix A times matrix B, then that's a little bit more complicated. So today, honestly, we'll get through probably number 20, 24 here. Okay. And really, the rest of this is just different ways. So in these first few examples, they've given you two named matrices, and they ask you to basically find the operation. Okay. In 13 through 16, right, we have evaluate the expression. So what they've done is they have, they haven't given you two named matrices and given you basically a matrix equation to solve it. Like for example, in number 16, let's pop this open. They've kind of written a matrix equation for you. Make it a little bigger here. All right, so in number 16, you can see that you have a matrix in here. It looks like a 1x4 matrix. So see this 1x4 matrix, right? Right down here, plus another 1x4 matrix. And then we have some parentheses, and the whole, once we add our matrices together, then we're multiplying by a scalar of 1/2. So your order of operations that you've learned for, forever, order of operations, those apply to matrices as well. So because I have two matrices that are getting added together in the parentheses, I'm going to do that operation first, and then I'm going to multiply by my scalar. So for number 16, for example, I have 1/2 out front, right? I'm going to deal with that later. I'm going to go ahead and do my matrix addition that's inside my parentheses. So I have a 1x4 plus a 1x4. So I'm going to end up with another 1x4. So my first row, first column is going to be 5 plus 14, right? So 19. Then I have -2 plus 6, which is 4. I have 4 plus -18, which is -14. And I have 0 plus 9, which is 9. And now I don't really need my parentheses anymore, right? But I'm going to multiply everything by a scalar. So this 1/2 is a scalar. Your scalar could also be a fraction, right? And it's kind of like distributing, right? When you multiply by a scalar. So every element is going to be multiplied by 1/2. So I have 19 divided by 2. I'm just going to leave that as 19 divided by 2. Okay. I have 4 divided by 2, which is 2. I have 14 divided by 2, which is -7. And I have 9 divided by 2, which is I'm going to leave as 9/2. So that one's not too bad, right? All right. Then we get to, oh, never mind. Well, I didn't assign your homework for this, but I can show you anyway since we have a little bit of time. I was just looking because you have 1 through 17 and 21 through 23. So we skip over these, but it says to use the matrix capabilities of a graphing utility to evaluate the expression, round your results to the nearest thousandths if necessary. So you can see, like with number 20, we would have a bit of a limitation if we were using our online matrix capability. And I will search again. The last time I looked for a matrix tool was last year. I look every year for a better matrix tool because, oh, I didn't mean to do that. Because honestly, also not what I wanted. Honestly, it keeps thinking I'm scrolling it. Sorry. All right. What I'm trying to say is that the TI calculator has everybody beat on matrix operations. There's no website out there that does anything close to what that does. For those of you who don't have a TI, there is an app that you can buy that's a TI simulator for your phone. And I think last time I checked, it was a couple dollars. Or you can kind of muddle through using an online tool, and that's okay too. Not muddle through, it just takes a few more steps. So what I mean is if I was trying to do number 20 and I was trying to use a matrix calculator, the TI is nice because I could just assign each of these matrices. There you go, Aiden. Aiden's going to program it for me. I know. I don't know why there's not a great matrix calculator out there. Maybe one of you guys can find a great one for me and let me know. So if I was programming this in my TI, okay, I would basically take this first matrix and I would call that A. And I would put that into I would edit matrix A, and I would put all my elements in, okay? And then I would take this second matrix and I would call it B. I would go in my TI, edit B, and put that in there, and take my third matrix and call it C. So then once I have all of these named in my TI calculator, they've been edited, they've all been put in, I literally have to go into my TI and I type -1 times, and then you hit the matrix button and you hit element A, okay? Plus 1/6, and then use your parentheses, right? Times B plus C. And your TI will pop out these are all these are all 3x2 matrices. Your TI will pop out a 3x2 matrix that is the solution. So you have to define the matrices, right? Then you just put the equation in and it pops it out. When I'm saying the limitation of at least the matrix calculator that I use, and maybe there's another one out there, or maybe Desmos will finally figure out how to do it, and I'm not sure, is you'll notice there is only 2 matrices, right? So you're going to have to be a little bit more creative when you do it. You can't assign all 3 matrices and then put the equation in. So what you would have to do is you would have to call the green and the blue matrix A and matrix B. So let's just do it really fast. And that's pretty much all we have for today. So we'll just wrap up here. 5. Oh, we need to make our matrix bigger. So we have 5, -1, 3, 4, not 41, 4, 0, 13. So you can see it's also not ideal in your TI, you can put in that this is a 3 by 2 matrix. It'll make it the right size. Here, they just assume that it's square. We just leave that last column blank. Okay, so what I'm doing is I'm putting the green matrix over here as matrix A and the blue matrix as matrix B. Okay, so make it a little bigger. And I have 7, 5, -9. So Aiden, you can invent that for me, right? You can invent a better matrix calculator, a free matrix calculator. So what I'm going to do is I'm going to have to, since I can't put all 3 in, I'm going to work on, this side of my equation. I'm going to work on adding these two together and multiplying by 1/6. So that I can do. I'm going to clean everything up here. I'm going to do 1 divided by 6 times A plus B. Okay, so I've basically evaluated the second half of my equation. I have 1/6 times A plus B, and I get this value for this matrix here. Okay, now because I only have 2 matrices to work with, this is my new simplified second half of my equation, right? This is my new simplified second half of my equation. So what I'm going to do is I'm going to take this solution and I'm going to insert it into B. So this is my solution to the second part, right? I'm going to put that matrix into B. Okay. And now I'm going to rename matrix A as my orange matrix so that I can do that operation. So it's not terribly hard, but it's just more steps. It's just not as streamlined. And is that a -1, I think? -1. So now what I'm doing is I'm putting the orange matrix in as matrix A. Okay. And my solution to my second half of my equation, my 1/6 of these two added together, has been inserted into matrix B. So now my equation is going to be -1 times A plus matrix B, because matrix B is all of this together. Matrix B is 1/6 of my 2 matrices. And then that will multiply my first matrix by a scalar of -1, add it together, and tell me what my result is. So, not horrible, not ideal. It works for what we need to do. Okay, so basically for your homework, you should be able to go through 1 through 17, and then we'll talk about 21 through 41 on Monday. We'll wrap that up with matrix multiplication. And just to give you a quick heads up with matrix, I'll tell you this today so that when you hear it again on Monday, we can let it sink in. When you want to multiply 2 matrices together, I'll just pop this one out really fast. When you want to multiply 2 matrices together, you have to look at the order of each matrix. So this matrix here, if I wanted to multiply A times B, okay, A is a 3 by 3 matrix, right? It has 3 rows, 3 columns. B is a 3 by 2 matrix, right? So in order to be able to multiply 2 matrices together, they don't have to be the same order matrix, okay? The rule is that the number of columns of the first matrix has to match the number of rows of the second matrix. So because these both contain 3, then we're able to multiply, and our resulting matrix actually is a 3 by 2 matrix. And I'll explain why once you do it, it kind of makes sense. But I just wanted to let you know, so the rule for adding and subtracting matrices, right, is they have to be exactly the same order. When we're multiplying matrices, the number of columns of the first has to equal the number of rows of the second, because they basically, in order to be able to do the multiplication, you need those to match up. And then the result is the number of rows of the first times columns of the second. So I will go over that again on Monday when we get into it, but I think just hearing it more than once is probably a good idea if you've never heard that before. So, all right, that's all I have for you guys today. Thank you for coming. Thanks for sticking in there. I know that was just a lot of material to get through. Let me know if you have any questions, and I hope you have a great day.